Yeah, welcome back to the channel. Hope everybody is doing well. And today we are taking a look at the Flir CM46 AC/DC clamp meter. This unit retails in the UK for around about £240 recommended retail price. And I purchased this instrument as I was interested in the AccuTip function that we'll get into a little bit later. So as I said, this is a Flir unit, and then you see a fairly standard clamp meter. It comes to you boxed in one of their nice, fairly fancy boxes there that usually end up in the bin. Inside the box you get obviously the instrument itself. You get a canvas case. Inside the case you have one little pocket in here. It's not elasticated or anything, just straight pocket to put all the probes in with it. And then on the other side you have a little loop for the instrument, but it really is on its limits. Try and put them up there. It's not elasticated, obviously, just a Velcro loop there, and you see, if I take it up to close to you, it really is on its limit for getting around the meter. To be honest, I don't tend to use it, although it seems to hold it reasonably well. Push him away, obviously logoed up with the Flir brand name there, and then also inside you get this is a getting started guide. The full manual you'll have to download from the Flir website. So this is around about 4 or 5 pages of basic instructions, and then it's repeated in multiple different languages again here. 4 to 5 pages for each language. So you have that there. You have a little paper guide on again in multiple languages. Opens out not as many languages as you have for the getting started guide, and this is for the test lead set, which is the T80 test lead set that comes with the instrument, which is naturally these two little fellows that you see down here, and then you also get a card for activating your warranty. Leads themselves, these are gold plated by the looks of it, GS38 caps on them that are removable. You don't get any crop clips with them. I have in previous with the Uni T one, I have these crop clips from RS Components. Again, it's 816-170 is the part number. These do kind of work with the lead, but obviously you can see there that it doesn't house itself fully onto the test probe. So there's that one there. What you do see here in the background is this Bryman insulation multimeter, the BM877. The probes that come with this are very, very similar. You can see them there. You'd almost say they were exactly the same. So that's those there, and this set does come with a set of crop clips, and these ones do fit much better onto Flir probes, so you can use them or buy a set from Bryman themselves and use them if you need a set of crop clips for the instrument. Where do I put my red cap? There it is. So that's those there, and the final element you get is this thermocouple lead. A fairly basic thermocouple there, K-type. So we'll zoom in to the instrument itself. Okay, a bit of a closer look at the instrument itself. You can see input jacks down here at the bottom. The input jack for ohms, microamps, capacitance, volts has a blue marking on it. When you move up to the function switch, any of these positions with a blue marking on them indicate you have to use the jack there. The white ones indicate that you have to use the clamp function up there. And obviously the common there input rating is Cat 4 300 volts and Cat 3 600 volts. So you see the display in the middle there. Underneath that you've got 3 function buttons for peak measurement, average, mode change between AC/DC, hold it in for backlight, then just measurement hold, and then a relative function there as well. So we flick them round onto the first position. This is for volts. Voltage will read up to 600 volts, AC or DC. Tolerance is 1% and 5 digits for both AC and DC. Always defaults to AC, and you can hopefully see there's a little VFD symbol up there as well. Whenever you're on an AC measurement, a low pass filter is enabled automatically on the instrument and cannot be taken off. So switching around through modes, you then move on to DC, AC/DC mode it has, and when you on that, the accuracy goes down. It goes down to 1.2% and 7 digits on AC/DC mode. You then go to frequency and your filter is enabled again, and then you go to non-contact voltage function with the actual NCV probe is in the top of the current clamp up there, as indicated by the little symbol there. Oh, I appear to be live. Yeah, oh, interesting. Yeah, we'll have a bit more of a play with that later on. I suppose it's good that I'm alive, isn't it, really? Okay, so in final press, we'll take you back around to the AC voltage function there. Next function, we're on to a clamp function, so we're up here, and this is the AccuTip measurement. They've made this specifically for use with smaller wires. The accuracy on this is 1.5% and 5 digits for AC and 2% and 5 digits for DC. Measurement capability is only up to 60 amps though, and the conductor is max 8mm diameter at the top there. Again, you can use the mode function, and you can go to then DC, AC/DC, frequency, and then back to AC. With the AC amps, you can also hold in the left-hand function and you move to a peak mode. Detection on peak mode is over an 80 millisecond window. Long press it again, take it out. Short pressing this brings it into a min, max and average function, and then you can page through the min, the max, the min, and then the average measurement, and then back to collecting data. Again, holding it in to remove the function and return it to normal AC current measurement. Flicking the switch around one more time takes you to standard current clamp measurement, so then you're using this main part of the current clamp there. Again, you have AC mode that it defaults to, DC, AC/DC mode, frequency, and back to AC, and the peak mode will also work as well in there. And on DC, so just mode, just press the mode button, take it to DC. The peak function doesn't work in DC. It's purely an AC function only. For standard current measurement, it will read up to 400 amps, both AC and DC. Accuracy is 1.8% and 5 digits for AC below 100 Hz. Above 100 Hz, it goes up to 2%. For DC current, the accuracy is 2% plus 5 digits. And then next function round is ohms, continuity, and a diode test. So for resistance, we've got up to 60 kilo ohms measurement, and we are 1% and 5 digits for ohms. Continuity is triggered at 10 ohms, and the diode is a 2 volt test voltage, so quite low there. Accuracy is 1.5% and 5 digits on diode. Again, you're using the mode to go through. There's your continuity, and then we're on to diode test there, and then back to ohms again. Next digit round, and obviously we're back on the blue marked functions, so we're back onto jacks, using the jack down there. So next function is capacitance and temperature. Capacitance will measure up to 2,500 microfarads with a 2% tolerance plus 4 digits. Temperature, it will press the mode button and we can get degrees C there. No inbuilt temperature sensor, so you have to use the thermocouple that's supplied with the kit. And then the next press takes you to Fahrenheit, and then obviously back to capacitance. Temperature you are reading up to -40 up to 400 degrees C, or -40 up to 752 degrees Fahrenheit. Accuracy is 1% plus 1 degree. Then the final function at the top here is microamps. This is a series current measurement. You have to use the jacks, capable of reading up to 2000 microamps. And this has been designed specifically for use with HVAC flame sensors. So it has a specific function that the manual does explain and gives you the various tests you can use for different flame sensors. So set up to 2000 microamps, accuracy is 1% with 5 digits. So that pretty much covers the instrument. Just to say, jaw capacity on this is maximum 30mm diameter. If we flip over on the back there, we have battery case which holds 2 AAA batteries, and we have UL listed independent certification there. And that's pretty much the lowdown of the instrument. So you should have seen a few tests going along as we went through the measurement functions. Now I'll put this table up here. This is all the accuracy tables all upon one sheet. So you can pause the screen here and take any information you'll particularly want. You'll see that the only one I really struggled with was the capacitance mode towards the upper end of the capacitance values. It seemed to get out of tolerance there. All the other measurements were totally within tolerance and good set of results. So I'll reconfigure and I'll show some of the measurements that I struggled with and some of the others that didn't appear whilst we were doing the function review. Okay, quick demo of NCV mode, non-contact voltage testing. We've got a tester here. You can see it was reacting to me a little bit earlier on, but it's stopped doing that now in the same manner, so I'm not sure why. I presume there was something else that was on and I was acting as an aerial. Either that I'm no longer alive and I've not realised, which would be slightly inconvenient. But anyway, let's move it closer towards. We've got our mains lead for the Mega here. It will pick up on. It should slowly. There's 2 dots as we get closer. There's 3 there. So it does work reasonably well. So the other way I can test this NCV mode is with the field sense on this fluke proving unit. I probably should have done that first. You see you get the dashes and beeping, and as you get closer and closer to the unit, it'll eventually turn solid tone, and you get 1, 2, 3, 4, 5 dashes up on there. So yeah, it still is a little bit, so you say I can wave it around, and it's a bit like the voltage pens in that respect, but it is fairly usable, not too bad at all. Okay, a little demonstration for AccuTip in operation. You can see here I'm actually set to the standard current measurement, and my clamp is positioned with the wire through the middle of the clamp, fairly well centralised. Put the display back up. We'll inject 5 amps, 5 amps AC, and we've got pretty much 4.995 there. So we'll flip it to AccuTip mode. We'll stay in the centre there, and we'll bring it down to kind of where it should be, sat in the tip there. And we've got smack on 5, probably a little bit more stable. Let's go 10 amps. We've got 10.06 there, still in AccuTip mode. Let's push it back up to centre and switch to standard current measurement. And we've got 10.07 there. So it does appear to be a little bit of a difference, but it's not fantastic. I'll put a complete table up of test results with more measurement points, both AC and DC, and you'll see it's a bit of 6 of one, half a dozen of the other. Some readings are better with AccuTip, some readings are better just in standard current measurement. So as far as my little tests went with regard to this AccuTip function, I've not really found it to add any value to the instrument. All the readings were within specification for all the measurements, and it's not as though AccuTip gives me any extra resolution. So yeah, not really sure of the advantage of it really, but that's AccuTip for you. Okay, on with some capacitance measurements. I've actually struggled with this one a little bit because the actual range of the instrument takes me way beyond the range on my decade box. This is made more, I guess, towards slightly more electronics, down 100 nanofarad down to picofarads, whereas I only have a microfarads range on the Flir CM46 there. So I can go 0.1, and you can see we're a little bit out, but by the time we get to 0.4, it's back within spec really. Back down, I've got 10 microfarads, we see 10.2, which is within spec. If I wind up to 47, and we can see we're actually at 49. It was 49.2 when I did the actual measurement, and that slightly drifts out of specification. And from here on in, I get a bit of a hit and miss as to readings that are in tolerance and some readings that are out of tolerance. I'll say one thing for it, it is extremely quick. This is a 1 millifarad capacitor. Put it in now, and there's your result, 1.056, but it is a little bit, drifts up to 1.064, 0.069, so it is a little bit out of tolerance, but it is quick. I guess it depends how much tolerance you want from your capacitance measurements for an electrician. Perhaps just to tell that a capacitor is more or less within value and is okay. And yeah, there's the capacitance function there for you. Okay, we'll go for some diode tests. We'll just short the leads out, and you see you get 0 volts, but there's no beep there at all in this. If I can keep my hands out of the way, there's the red one, and it does light up. We get voltage. Green one, a little bit higher, again does light up. That gets voltage. Blue one, we don't. It does light up, but we don't get a voltage reading. And the white one, again, it does light up, but we don't get voltage reading. Those two only just light up, so it's quite low on the voltage measurement. Take him out of the way. Just some normal diodes here. We've got a couple of stud diodes. 0.45 is okay. This one's actually reverse polarity, so it doesn't work. It does work that way. Back again. That's a Zener diode, 0.6. That's a Schottky diode, and we've got just a normal power diode there, 1.014. And our little, it's a high intensity LED up there, 1.8. It does light it a bit, but not very well. So we'll just change the mode over to continuity, see how quick he is. So pretty quick latching on that. That's pretty good. But it's not the loudest. Okay, and what we've got there, you can see is 82.2 dBA. That's at 200 mils distance. So we've got our U4061 ion volts DC in continuity mode, 1.6 volts, so quite high there. Diode mode, it's 2.5. Yeah, so not the highest there. That's probably why it didn't light up the blue and the white LED very well. And then normal resistance mode is again 1.1.5 volts. Okay, we'll give a little demonstration of peak current detection or inrush measurement. Flip the meter around to amps. We are set up on our 50-turn coil table there. We will switch the light on, so you can see, and we'll hold down peak button. So we are now in peak mode. We are at 0 amps. I'm going to inject an 80 millisecond inrush current of around about 300 amps. And there you see it's picked that up at 300.4. Now we'll just go again. Sometimes this works. If the next reading is above what you get, you see it will detect. You don't have to come back out of inrush mode in order to make a new measurement. If the measurement is substantially lower than the one you've captured, then you will need to come back out and go back in to peak mode. So that's an 80 millisecond test there. I'll just rearrange and bring in another test. So this test will be more of a startup ramp, where you'll see it will decay slowly down over the 80 milliseconds as a rather stay constant. So just reset everything, put the light back on, and we'll go again. So you can see the reading here is 216.8 amps. Highest reading would have been somewhere around about 250 amps for the first 20 milliseconds. So it looks like the instrument isn't picking up the highest amplitude within that 80 millisecond time frame. It looks like it's doing some sort of an averaging calculation over the specified time period and gives you the reading for that, as opposed to the actual peak value that I've injected. Okay, so that's it. That's peak measurement. Works on AC mode only, but will work with the standard amps function and the AccuTip function. Okay, demonstration of the DC microamp measurement. You can see, if I zoom out a little bit more, we are set up here onto the top function, so we have to use the jacks for input. We are injecting 2 milliamps or 2000 microamps, and we are reading 2008. We'll set him down to 50%. 1002. Let's go half again. 500 microamps. We'll go half again. 250 microamps. Smack on. Pretty accurate for a microamp measurement, really, from such a small instrument. 100.1. Can't complain at that, can you, really? 50 microamps. 10 microamps there. 9.99. Should we do it? Let's go 1 microamp, see what we can do. 0.9 microamps. So yeah, pretty decent accuracy from the microamp measurement there, certainly for the type of sensors you get on HVAC systems that it's intended for. That's a pretty good function and good and accurate. So yeah, that's the little demonstration there of the microamps function. Quick demonstration of the temperature measurement function. I don't have a thermocouple simulator, so the best I can do is to do this with a millivolt source. I've set the millivolt source to 0 millivolts, and I've got 19.8 degrees C. That's the offset that I need to apply in order to get an accurate reading. So looking at a thermocouple table, 19 degrees C is 0.758 millivolts. So to get the reading accurate, I need to subtract 0.758 millivolts from all the values I enter. So if I enter 0.758 minus millivolts, that should take me down to 0 degrees C or thereabouts. Looks like it needs a little bit more, but that's within spec. So my 100 degrees C will now be 3.337 millivolts. And there's 100 degrees C smack on there, and then 400 degrees C is the maximum, so that will now become 15.637 millivolts. Okay, there. And there's your 400 degrees C. So that's the best I can do for demonstrating the temperature measurement function, as I don't have a proper K-type thermal simulator. But there you go, that's it. Okay, so that's the review of the Flir CM46 400 amp AC/DC current clamp. Pretty good instrument. Vast majority of the readings were within specification. A little bit of an issue with the capacitance function, but other than that it was all pretty good. AccuTip, I didn't really find that was of any benefit for the way I tested it. No increase in resolution or accuracy in comparison to just reading it with the normal clamp function. So to my mind, if you're buying this instrument purely for AccuTip, then you're going to be a little bit disappointed. But other than that, it's good manufacturer, good reputation behind it, nice quality accessories with it, so it's all good in that respect. Whether it's worth the £240 in the UK in comparison to other instruments, I'm not so sure about, but I'll do some other tests on some other clamp meters I got and see how they compare to this one. So that's it for this video. Thanks for watching. Hope you found it useful, and I'll see you again in the next one.